So this is going on page 51 when we're done. This is operations with rational expressions review. That word implies what? You've already done it, right? So, but we're going to go through each one of these, and we're going to talk about what's legal and what's not. And I hope you commit those things to memory, because I think some of you think some things are legal that are totally not, all right? But this is also one of the things where, I mean, if all you've ever done is ignore fraction rules and just thought you could just ignore them for the rest of your life, you're going to be in a world of hurt on this stuff because, yeah, you just can't change it to a decimal. All right. So looking at number 1, my directions say to, well, it just says simplifying. So I'm going to simplify this. So when I go to simplify this, can I cancel this 4 with this 2 and make this 2? No. Can I cancel these ends? No. Can I reduce this to 1/3? No. No combination of that. If you have more than one term in the numerator and or denominator, do not start canceling anything out ever. Okay? Big time no-no. So what we need to do is, because it's telling us we should simplify it. Sometimes you can't simplify things, right? Just like if I have 1/3, I can't simplify that. But I want to factor these to see if I can. So I'm going to rewrite a big fraction. And sometimes when you do things like this, I would suggest that you just work with the numerator and leave the denominator alone, then just work with the denominator. But sometimes you can work with both at the same time as long as you're not making things up. This is one where I think it's safe to kind of work with both at the same time. Just know that they're separate. So I'm going to need to factor this, which means I need to split my middle term. 2 numbers that multiply to give me 36 that have the same sign combined to give me -12. What would they be? -6 and -6. So 4n squared minus 6n minus 6n plus 9. Okay? So then I'm going to go ahead and do the same thing with the denominator. So I need 2 numbers that multiply to give me 54. The signs will be opposite, so they'll have to subtract to give me 15. Does anything just pop in your head? Probably not, and that's okay. All right? If something doesn't just pop in your head and you have to stare at it for more than 3 seconds, you're wasting your time. Don't keep staring at it, because sometimes I'll stare at it forever and nothing's going on here, so I don't know why we're still staring at it. Then you revert back to what you learned to do when you very first learned to factor. I'm quite sure your teachers probably made you write down all the factors, right? You're at a place now where you probably don't need to do that, but sometimes you do, because that'll help like kickstart your brain. So 54. So I know my factors would be 1 and 54. Well, clearly those don't subtract to give me 15. Then I also know they're 2 and 27, because that's how I got it. That still doesn't subtract to give me 15. Okay, and then 3 and, well, is 54 even divisible by 3? Do you know how to look at a number and just know if it's divisible by 3? You add the digits. So let's just pause on this for a second. If I add 5 plus 4, it's 9, right? Is 9 divisible by 3? Yes, then 54 is divisible by 3, and I don't have to guess and check. Okay, and it surprises me that sometimes at this level even, y'all don't know that trick. And let's think about, what if I had 1242? And we have to find some factors. So I know some of y'all would just start guessing and checking everywhere. Obviously, it's divisible by 2, but is this divisible by 3? Yes, because 1 plus 2 is 3, plus 4 is 7, plus 2 is 9. So when I add all these up, I get 9. So not only is this divisible by 3, but that trick also works for 9. So this one's divisible by 3 and 9. This is divisible by 3 and 9. Does that make sense to you? That can be very helpful when you're trying to break down numbers that you just don't look at and it just doesn't automatically trigger something. So yes, this is divisible by 3. 3 goes into 5 once, with 2 left over. 3 goes into 24 18 times. If I subtract those two, am I going to get 15? Yes, I am. Those are my factors. So I get 2n squared plus 18n minus 3n minus 27. Can I cancel anything out right now? No. All right, so then we move on, and we're just going to go ahead and factor by grouping, just doing the numerator and denominator separately. Here I can factor out a 2n, leaves me with n minus 3. Here I factor out a negative 3, leaves me with n plus, no, wait. Oh, yeah, n minus 3, I'm sorry. And then here I can factor out a 2n, leaves me with n plus 9. Then I factor out a negative 3, leaves me with n plus 9. Okay. All right, well, bless you. Can I cancel these -3's out now? No, because here's what I went to. Look at this and think about what we have. In the numerator, right now I have 3 terms, right? I split it, it became 4 terms. When I factored, now I have 2 big terms, but the addition and subtraction is what separates them into terms, right? So still no canceling. Then I factor, or complete my factoring rather. I have 2n minus 3 times n minus 3 over 2n minus 3 times n plus 9. At this step, I now have it down to 1 big term in the numerator and 1 big term in the denominator. Yes, there's like 4 little terms in here, but overall this is all 1 big term, 1 big term. Now you're allowed to actually reduce things, and 2n minus 3 over 2n minus 3 becomes 1. So then that leaves me with n minus 3 over n plus 9. Can I cancel the n's out now? What did I do? What did I put? Oh, wait. Ugh, poop. I did it on both of them, too. Goodness. Okay, thank you. Chutes and ladders. Okay, there should be a 2 here. I can see me messing up on one. I did it on that one, too. Okay, so this one is also, you're right, and I knew that because that's a perfect square trinomial. Oh, 2n minus 3. Thank you. Okay. Thank you. I'm sorry if I confused you by my stupidity. Can I cancel the n's out now? What about the 3, the -3, and the 9? No. Okay. And I've already asked you questions like that a lot this school year. I'm going to continue every time it comes up because that's bad, real bad when you do that. The student I had last year, I have him now in calculus on a quiz last week. He got to something like that and canceled the n's out. Bless you. So I told him I was going to disown him. And she's not even going to go to math. I was going to go to math prison because you cannot afford mistakes like that anymore. You have to know when it's okay and when it's not. All right? We good? So yes, it is over there somewhere, I think. Maybe it's not. It's not. I need to add it. Ooh, it's not. I don't care. He's still going to jail. Okay. I need to make another one. All right. We all good then? Just be careful on stuff like this, especially when there's fractions with lots of stuff in it. If you have crazy handwriting that sometimes you can't even read, that could be a problem for you. All right. So I'm going to multiply fractions. Multiply and divide. We'll start with multiplying. So when we multiply the fractions, you just multiply straight across. So what's really happening here is this can already become 1 big fraction, but where they were separate, I would have to have parentheses, like so. And that's kind of step 1. I've multiplied my fractions. Okay? I mean, you could rewrite it like that if you wanted to, but at the same time, you know, who wants to rewrite all this a bazillion times? Okay, so then we're going to move on to, as I simplify this, can I factor this right here? Yes, this is a difference of squares, so this is 7 plus y times 7 minus y times 48 y cubed. All right, so then in the denominator, so now I had 2 terms. Actually, this is still just one big term. I had 2 in the first and 1 in the second, but when I multiplied them, it just kind of became 1 big one. And this right here, can I factor anything out? The 6y, good. So 6y, and then this is y plus 7. And then I'm going to factor this. A is 1, so I can jump to my 2 parentheses here. And I have y and y. 2 numbers that multiply to give me 21 with the same sign. -7, -3. Everybody good so far? So everything's become multiplication in the numerator and the denominator. I can start to reduce things. So when I do this, let's see. 7 plus y and y plus 7 are the same thing. Is 7 minus y and y minus 7 the same thing? No, it's not. You can add in any order, you can't subtract in any order. So I got to leave that for now. Then I have this 1 term and this 1 term. I can reduce these. 6 goes into 6 once, goes into 48 8 times. And then this y can cancel with one of those and it becomes y squared. Okay. So I'm going to rewrite what I have. And once you start marking a bunch of stuff out, be careful with, so I know I marked that out. I still have 7 minus y. This became 8y squared. This completely reduced out, so did this, and then I have y minus 7 times y minus 3. Everybody with me so far? So it doesn't mean I can't reduce it anymore. I just can't cancel things out at this step. What could I factor out of 7 minus y to make it into y minus 7? Negative 1. So if I factor out a negative, that becomes y minus 7 times 8y squared over y minus 7 times y minus 3. Now I can reduce some more. Because when I reduce these, be careful, because there's still a negative here. The negative doesn't reduce out, because this wasn't negative down here. So don't forget about it when you rewrite the answer. And we get negative 8y squared over y minus 3. Can I reduce one of these y's with this one? No, because I have one term in the numerator, but I have 2 in the denominator. Don't be making up math. Okay? What questions do you have? Okie dokie. So let's look at number 3. We are dividing fractions here. What's our rule for dividing fractions? Keep it, change it, flip it. Do I need common denominators? No, not when you multiply and divide. So this first term, this is a fraction. Divided by this, that doesn't look like a fraction, but is it one? Yes. Just put it over 1. And some of you will need to literally do that. Not all of you necessarily, but you know whether or not you need to do that so you don't make stuff up. And some people choose to never skip any steps ever because they're afraid to, because they know they'll do something ridiculous. And some of you skip too many steps and make ridiculous mistakes, and you need to back off a little bit, but it's fine to skip things sometimes. All right, so I'm going to keep, change, flip, but when I do that, when I keep this one, I'm going to go ahead and factor. So in the numerator, I can factor out a 30c squared. And then that'll leave me with c minus 2. And then the denominator, I have 3c. Times 1 over, can I factor out a GCF here in this one? Yes, so I'll factor out a 2c. That leaves me with c squared minus 8c plus 12. Okay. So because I'm multiplying, just multiplying straight across, again, you can think of it as one big fraction already so that we can simplify some things out. This 2 can reduce with this 30 and make it 15. This c can reduce with one of those and just make it c. I don't know why I started with the second fraction and not the first one. It wouldn't matter. I could have started reducing with this, but I didn't, because all this is being multiplied. So 3c then divided here, 3 divides into 15, leaves me with 5. And then this c completely cancels out. So I think I'm finished reducing. Before I start rewriting, I want to make sure I don't lose myself in all my cancels, okay? So when I'm looking over here, I'm left with this 5. I'm going to circle it so I don't forget about him. And then I have c minus 2. This is all gone. That's all gone. So I just have that right there. All right. So that means in the numerator, I am left with 5 times c minus 2. In the denominator, I'm going to go ahead and factor that as I rewrite it. So it'll be c and c. 2 numbers that multiply to give me 12 with the same sign that combine to give me negative 8. Negative 6 and negative 2. So then this will reduce, and we are left with 5 over c minus 6. Okay. Questions? Alrighty. Adding and subtracting. What do I need when I add and subtract fractions that I didn't need when I multiplied and divided? Common denominator. Do I have one in number 4? Yes. Okay? So I want you to think about this because I still see y'all do weird things with the denominators sometimes. Because I have a common denominator, when I actually subtract these, do I do anything with the denominator? No. You've been talking this way since kindergarten. You just don't realize it because nobody probably ever put it together with you. But think of the denominators as things. Okay? So let's say we're in kindergarten and I can say, all right, so we have 5 apples. We're going to subtract 3 apples. That leaves us with 2 apples. You see how the denominator is the same? The denominator is my apples. That's why they have to be the same. I can't say that, 3 apples minus 2 oranges is 1 grapefruit. Like, it doesn't work that way, right? Okay, so, and then when we do this also, because it's subtraction, we have to make sure that we have parentheses there so we don't mess that up. That's really the bigger mistake here. That's not a fraction mistake, really. It's just a process mistake, I guess. So I'm going to rewrite my denominator because it doesn't change. And then I do 9m minus m gives me 8m. Negative 12 minus 28 is negative 40. Negative 12 minus 28. Okay, you took 12 away, you take another 28 away. All right, so then I can factor. Here I get 8 times m minus 5. This is the difference of squares, so I get, x. M minus 5 times m plus 5, or vice versa. I don't know why I'm not consistent when I do that. These two reduce out, and I am left with 8 over m plus 5. What questions you got? Okay. All right, so let's look at number 5. So we are subtracting. We need a common denominator. So let's say, so just ignore this for just a second, and let's say that I have 1/6 plus 1/4. Okay, I don't even care what the answer is. We're just going to talk about denominators. One way to get a common denominator there is to just multiply the 2, and my common denominator could be 24. Does that make sense? That totally works. Okay, but you were also taught to find the least common denominator, right? What would be maybe it's a matter of opinion, but what would maybe be a better denominator? 12, right? So instead of just multiplying these together, these are both divided into 12, and 12 is a smaller number than 24. And if my numerator was crazy, I would rather not have to multiply it by too much. Does that make sense to you? So that's kind of what we're doing here. Yes, we can just multiply these two together and get a new denominator, but maybe we don't have to do that. Maybe we can get 12 instead of 24. That's kind of what I'm saying here. So let's go ahead and before we start subtracting, and so before we worry about a common denominator, let's go ahead and get this factored and see if maybe we can make this a little easier on ourselves. So in the numerator here, I want to factor this, so I need 2 numbers that multiply to give me 51 with opposite signs that combine to give me 2. All right, so 51, I would imagine, is also one of those where the factors don't just pop in your head, right? So it's not a common one. So obviously not divisible by 2. Is 51 divisible by 3? Yes, because 5 plus 1 is 6, right? So I know it's divisible by 3, so my factors would be 1 and 51. That doesn't work. 3 and, all right, well, 3 goes into 5 once with 2 left over, so that would be 17. 3 and 17 do not subtract to give me 2. These are prime numbers, which tells me this is it. Those are my only choices. So can I factor the numerator? No, it's not factorable. So I'm just going to rewrite it. All right, couldn't factor it. P squared plus 2p minus 51. So let's look at the denominator. I need 2 numbers that multiply to give me negative 27 with opposite signs that combine to give me negative 6. Can I factor that one? Yes. Okay. So I can factor that. It's going to be p, and let's see, my numbers would be a negative 9 and a positive 3. Right? And then remember, I'm subtracting 4 over p plus 3. Now, do you see maybe a better common denominator than just multiplying them? Yes, because I can keep this denominator and it's just fine, but I only have a p plus 3. I would need to multiply this by p minus 9, which means I'd have to multiply by p minus 9 up here. That's how we multiply by a factor of 1, that's how we get our common denominators. Yes? So I'm going to rewrite this again. So my denominator now is p minus 9 times p plus 3. And then this first part was p squared plus 2p minus 51 minus, and then I'm going to go ahead and distribute as I do this. That would be 4p minus 36. Okay. Everybody with me? Okay, so then I'm going to rewrite my denominator again. P minus 9 times P plus 3, because that's not going to change right now. And then I'm going to actually do the subtraction. So P squared, that's the only squared term, so that's P squared. 2P minus 4P is negative 2P. Negative 51 minus a negative 36 is what? Negative 51 minus a negative 36. Okay. Those dang integers, man. All right, so at this step, I can't reduce anything. But maybe now that I've changed my numerator, maybe I can factor it. Can I find two numbers that multiply to give me negative 15 that subtract to give me negative 2? 5 and 3. Okay, so I can say that this is going 2 P's in here, and this would be a negative 5 and a positive 3. So that's P minus 9 times P plus 3. Now I can reduce those, and my final answer is P minus 5 over P minus 9. What questions you got? We good? I would highly suggest that you skip a minimal number of steps if you skip any on these, just because this is where stupid little mistakes with signs and things that get very frustrating for you happen when you start skipping a bunch of steps. Okay, we good? All right, so number 6, we're going to add these. We need a common denominator. There's really only one, well, there's, I guess, an infinite amount of choices, but you don't want to make things difficult on yourself. This is one where I would say, we're just going to multiply. It's just going to be h minus 2 times h plus 5, right? So I would normally skip writing the other stuff in here, because I could say, all right, I know that this is h minus 2 times h minus 5, which means this becomes 3 times h minus 5. This one becomes 5 times h minus 2. But if you need to write them out, write them out. This has to be multiplied by h minus 5 over h minus 5. And this has to be multiplied by h minus 2 over h minus 2. I mean, do what you got to do, but when we're always writing everything, that weighs us down here. So 3 times h minus 5 is going to give me 3h minus 15. 5 times h minus 2 is going to give me, and then we're adding here, plus 5h minus 10. So then that means I get 8h minus 25 over h minus 2 times h minus 5. Can I reduce this at all? Can I factor out a GCF in the numerator? No. So if I can't factor a GCF out of the numerator is 2 terms, and I can't do anything about that, so there would be nothing else I can do. This is it. Okay. What questions we got? We good? All right. So then we have complex fractions, which always look way worse than they are. Okay? We've really already done a question like this. It just didn't look like this. So again, you got to make sure we're not making up math. Do not ever, at this step, try and start reducing anything, because you will do it wrong at least 98% of the time. Okay? Because you're going to try and reason through it, and it's not worth it. Okay? All a fraction is division. 1/2 just means 1 divided by 2, right? That's all it means. So it's just this divided by this. It's just written in fraction form. By the way, did you know that the division symbol, the reason it's like that is because it represents a fraction? That's your numerator, that's your denominator. That's all division is. So the numerator is 15x minus 10 over x minus 8. Since it's division, I keep the numerator, I change it to multiplication, and I flip the denominator. X squared minus 12x plus 32 over 3x minus 2. So notice that on this particular one, when I rewrote it, I could have factored along the way, but I didn't. I would suggest that most of you don't, because I don't want you to, this already makes your brain hurt. It's not difficult, but I know visually it scares you. So I don't want you to do something weird when you're trying to just rewrite it like that. So now that we have it rewritten, we can combine it into one fraction and factor all at the same time. So I can factor this, okay, 5 times 3x minus 2. I can times, and then I can factor this. So I've got, let's see, my 2 parentheses, x and x. 2 numbers with the same sign that multiply to give me 32, combine to give me negative 12. 8 and 4, negative 8 and negative 4, good. The denominator, I have x minus 8 times 3x minus 2. Even though as you start to write that numerator, you can see that things are going to cancel out, you have to finish it. Like your equality statements have to be true. These two things actually are equal, and you can't just randomly put stuff, all right? So now we can reduce. This reduces with this reduces with this, and my answer is 5 times x minus 4. And leave it alone. If you put 5x minus 20, it's not wrong, but it's not necessary. So by not doing it, you save some time, and you save maybe a careless error by just writing 5x minus 4 and not actually distributing, right? The flip side of that is, what am I trying to say? The flip side of that is if we actually ended up with 5x minus 20, you wouldn't have to factor it into this. You just stop and you're fine, okay? And as with everything, the process is more important than the answer. I've said that to a lot of people. I've had some questions about things like that. So showing your process is important. On the back of your test, on the top, you had to factor and find your irrational and imaginary roots, and then you had to write the fully factored form. So somebody came and asked me about their test because they factored correctly. They made up math to come up with their zeros. Don't know what was going on there. Then they put their, and so I didn't take off the whole thing. I took off 15 points because I don't know what was going on there. And then the last part was where you had to write out the fully factored form. And I counted that correct. He said, I don't understand how if this is wrong, this is correct. Like, because that kind of means these answers are right. I said, no, that answer does not match my answer key. It is wrong. However, you took your crazy weird zeros and you knew how to use them to do the fully factored part, which was part of what I was testing. So if I'd accounted, that's not the right answer, but it was the process that I was checking. Does that make sense? That's why showing your work is so important. So you can find, and I mean, that's how AP is graded. If I counted off twice, I'm punishing you twice for the same thing, and it doesn't work that way. Okay, so process is important. Being able to follow what you're doing, even if you skip steps, somebody should still be able to follow what you're doing. Okay? Maybe not somebody that needs to see every step, but you know what I mean. All right, so I would think that this one probably looks a little bit more intimidating than the last one. Because up here, I had, on the one above it, I had one big fraction over one big fraction. Here in the numerator, we have 2 fractions, and the denominator, I have a whole number in a fraction. So although at some point we're going to keep, change, flip, it is not here. You cannot change this, and you cannot do the keep, change, flip until you have one fraction over one fraction, okay? So it may have to look a little ugly for a little while, but it's really just you're working on 2 things at the same time. So we're going to keep this big fraction, and in the numerator, I'm going to combine those 2 fractions into one. Well, okay, I could do v cubed. What else could I do? Could I use v squared? I could. There's nothing wrong with v cubed because in the end you'd end up with the same answer. You're just adding more variables. So because I can't use v squared, that's what I'm going to do. That's going to be the common denominator to the numerator, which means this first fraction has to be multiplied by v over v. So that makes this first term 4v squared. Because I'm using v squared as the denominator, I don't have to multiply this fraction by anything, so it's just minus 1. Everybody with me on that? So then the common denominator of the denominator would be what? 2v. So this is like 1 over 1, right? So this fraction has to be multiplied by 2v over 2v. So that would give me, here, I'll write 2v in the denominator. So this first term becomes 2v, and then I didn't change that one, so it's minus 1. Okay, we good? Any questions at this point? So now I have a fraction divided by a fraction. Now I can do my keep, change, flip. So this is going to give me 4v squared minus 1 over v squared times 2v over 2v minus 1. Everybody okay with that? Any questions? All right, can I factor this first numerator? Is this factorable right here? Yes, this is a difference of squares. So this is 2v plus 1 times 2v minus 1 times 2v. All right? My denominator is v squared times 2v minus 1. So now I have my 2v minus 1 will reduce with this. This v will reduce with one of those. So in the numerator, I was left with 2v plus 1. I still have that 2. I'm going to bring it out front. And then I have a v in the denominator. And that's the best I can do. What questions you got? Let's back up a second here. At this step, before I went to this step, could I have canceled this v out with one of these? Yes, I could have. But I didn't because I had done the other ones. I wanted to see it might be better if you feel like you might make careless errors or make things up to put it all together before you start doing that. But again, that's kind of your comfort level and your skill level and whatever. Okay? We good? Any questions? All right. You need to practice this, okay? Like for reals, so that you make sure you're not doing the crazy things I'm telling you not to do, right? Hopefully you can catch yourself on that if that is happening, right? So go ahead and get that taped in, get started on your Delta Math, make good use of your time.